list of bibliometric laws. We have covered Bradford's law, right? We have seen the definition, we have seen the application, we have seen the advantages of bibliometric laws, Bradford's law, in the management of a library. Okay. Now, the next one is what is called as Lotka's law. This law was given by Alfred Lotka, who was in fact not a library scientist, but he was an statistician. And he was working in an insurance company. Right? He was working in an insurance company, and he gave this law way back in 1926. Okay. This law is in fact known as Lotka's law of productivity of authors. What is meant by productivity of authors? Productivity of authors means number of publications. For example, if I am a scientist, how many papers I write? That is a measure of my productivity as an author. Alright? So, he gave a law which is known as Lotka's law of productivity of authors. The importance of this law is that in any given literature, any subject, any period, okay, there are a number of authors. Some of them write only one article each. Some of them write, you see, number of authors writing 2 articles, number of authors writing 3 articles, number of authors writing 4 articles. This is the productivity. Am I right? Now, important thing is that in any given literature, if you have thousands of authors, any number, depending upon the vastness of literature, depending upon the period covered, there may be hundreds and thousands of authors. And in that literature, if we want to measure how many authors have written 1 article each, how many authors have written 2 articles each, How many authors have written 3 articles each? Simply you will have to do the counting. That is the only way. Am I right? How many authors have written 1 article? How many authors have contributed, 2 articles each? Okay. For example, in this class, there will be more authors writing 1 article. There will be lesser number of authors writing 2 articles each. There will be still lesser number of authors writing 3 articles each. Okay. So, if you want to calculate how many authors have contributed 1 article each, how many authors have contributed 2 articles each, and so on, the only way to do it, to measure it, to find it out, will be simple numerical counting. It is a tedious job. It is a tedious job. More the number of references means bigger is the volume of literature, larger will be the number of authors. More difficult it will be to count how many of them have written 1 article each, how many of them have written 2 articles each, and so on. It is a tedious job or not? It is a tedious job. But Alfred Lotka found out an equation on the basis of which, if you just know the number of authors contributing 1 article each, then you don't have to count the number of authors who will contribute 2 articles, 3 articles, 4 articles, and so on. Just what you have to count? Number of authors contributing only 1 article each. Other counts you don't have to do, because it will be done by the equation which Alfred Lotka has deduced. You understand my point? That is why this law is called as Lotka's law of productivity of authors. The equation which he found out is hello. So, what is that equation? The equation is very simple. The equation is that if you want to know the number of authors contributing 2 papers, then it can be calculated by number of authors contributing 1 paper into 1 upon n square, where n is the number of papers. Means this. If it is 2, then n is equal to 2. If you want to know number of authors contributing 3 papers, then n will become 3. If you want to know the number of authors contributing 4 papers, then n will become 4. So in this equation, what you need to know is what? What you need to know is number of authors who have contributed one paper in a given literature. Just count the number of authors who have contributed only one paper. And then rest is simple. You just have to write the number of authors contributing one paper into 1 upon n square or upon n square, where n is the number of authors contributing 2, 3, 4, whatever number of papers in a given literature. That is very, very important. Is that clear to you? Is that clear to you? The law is very simple. The law is the number of scientists who contribute n papers, write down, the number of scientists who contribute n papers will be 1 upon n square will be 1 upon n square of those who contribute only one paper in a given literature. Is it right? Is it okay? Yeah. You see, in fact, what did he do? He took into consideration chemical abstracts. And in chemical abstracts, he took into consideration the references appeared between 907 to 1916. And the field was chemistry. The field was chemistry. And from this he collected a total number of 6,891 names of authors or scientists. You know the given literature. What is the given literature? Subject is chemistry. Period is from 1907 to 1916. How many total number of authors are there? 6,891. That became the basis of Lotka's law. Means, out of this, he collected how many authors have contributed one paper each. How many authors have contributed? One paper each. Then he counted how many authors contributed? 2 papers each, 3 papers each, 4 papers each. Okay. And as a result of that, he was able to give the equation 1:1 upon n square. Okay? Means, if you take it just roughly, means 100 authors, if 100 authors have contributed one article each, okay, then 2 articles will be contributed by 25 authors. Alright? And 3 papers or 3 articles will be contributed by 11 authors. And 4 articles will be contributed by 6 authors. And 5 articles will be contributed by 4 authors. Right? This was according to this equation. 1:1 upon n square, where n is the number of authors contributing 2 papers or 3 papers or 4 papers, whatever may be the number. N may be equal to 2, 3, 4, 5. Do you understand? So this analysis led him to propose an equation which is called Lotka's law. Then he applied it to physics. You know, when any law comes into shape, when it is applicable to different vast field. So he applied this law, basically emerged from chemistry, then applied to other branches of science like physics, and he was able to give this law, which is called inverse square law. It is called inverse square law. Inverse square, it is inverse square. It is called inverse square law. Lotka's inverse square. Now, by now everything is fine. But later on, when this law was applied, to other branches of knowledge, then this figure became doubtful. This law may be good for fundamental sciences, like physics, chemistry, biology, right? But it may not hold good in other branches like engineering, like medicine, like in arts, like in humanities. So what people have done? Taking literature, this is very easy to do. This is very easy. Take any bibliography of any subject and just count the number of authors contributing 1 paper. And then apply Lotka's law, inverse square law. On one side you put the figure which is drawn by applying the Lotka's law, and on the other hand you do the simple counting. Both of them should match. But if it does not match, what does it mean? It means Lotka's law is not applicable in that particular area. You understand me or not? बात समझ में आ रही है आपके? This is very simple. This is very simple. What you people do, you also have a given literature. You also have a particular period of literature covered. In that, you calculate the number of authors who have contributed 1 article each. Right? Your sample is not a big sample, it's a small sample. Then by applying Lotka's law, you will find out in this given literature, by applying Lotka's law, how many authors will contribute 2 papers? Any figure? The equation आएगी. How many authors have contributed 3 papers? And so on. So that data has come by applying Lotka's law. Then what is the actuality? On the other hand, you have to do the simple counting. How many authors have contributing 2 papers? Count it. Put one side. Means on one side you have Lotka's results. Means results obtained by applying Lotka's inverse square law. On the other side you have simple counting, numerical count. Okay. How many authors, number of authors contributing 1 article? This figure you have to do in both the cases. Then number of authors contributing 2 articles. What does Lotka say? एक author का मालूम है, तो formula will calculate number of authors producing 2 papers each. Lotka का. अब आपने क्या किया? In the same literature, now you have counted how many authors have contributed 2 papers. Count कर सकते हैं ना, जैसे 1 का किया ऐसे 2 कर सकते हैं आप. And then you write the figure. This is the figure which you have counted. This is the figure which Lotka's law gives. Both should match. Both should match. Only then you prove that Lotka's law is good enough in such and such subject. But if it does not match, then you will say that Lotka's law, in its present form, in its inverse square form, is not applicable to this field. Then what it will be? If not n square, whether it is n cube, whether it is n 2.5, whether it is n 3.5, whether it is n 4. Do you understand what I mean? Do you understand what I mean? Huh? Not difficult. How do you prove Lotka's law in a given literature? Simple method. You have to calculate number of authors producing 1 paper each. That ultimately you have to do in any case. Then you apply equation. What? 1 upon n square. Through equation, how many authors will contribute 2 papers? How many authors will contribute? Authors contributing 3 papers. This is the article, author, article. How many authors have contributed 3 papers? This is the result calculated by applying Lotka's inverse square law. And this is the result which you have found out by simple counting. Ideally, both of them should match. And it does match in hard sciences, in fundamental sciences, it does match. But when it goes beyond hard sciences, then when it goes beyond hard sciences, then you find that in its form, which was given by Lotka, this law does not hold good. But saying this is not enough. You have applied it to your own sample of references. If it holds good, you say, yes, Lotka's law is okay. I have calculated. This is Lotka's equation. This is my own counting. Both of them match. Fine. Right? But one has to go beyond that. One has to go beyond that. What is that? You have to say, if not n square, then what equation it will be? Whether it will be n to the power 2.5 or n to the power 3 or n to the power 3.5. People have done it. People have done it in different samples of literature. Somebody whose name is Woos, W-O-O-S, he applied Lotka's law on the literature of information science. And he found that here the equation will be 1 upon 3.5, not n square. In information science it is 1 upon n raised to the power 3. What is the sum and substance now? What is the sum and substance now? Lotka law was basically given by taking into consideration the references of the subject chemistry. It was tested on the subjects belonging to the fundamental or hard sciences like physics, like biology, right? And to the limitation of fundamental sciences, this law may hold good 1 upon n square. But some people have challenged it, that even in hard sciences, the results may differ from one subject to another. It may not be n square in one subject, it may be something else in other subject belonging to that broad field of hard sciences. And certainly, if you apply this to the field of engineering or medicine, and especially in arts and humanities, the equation will be totally different. So this is an area of research itself. This is an area of research in any time you can do it. Not that this Alfred Lotka had given the law in the year 1926. He had shown you a path of research dealing with the productivity of authors in any given subject. You take any literature, you take any period, and then apply Lotka's law. If it does not hold good, then try to find out what holds good. What will be the exact equation? Whether it is n square or more. What more? Is it 2.5? Is it 3? Is it 3.5? Is it 4? You understand? Because productivity has far more increased, especially in this era of information technology. Productivity of authors has far more increased. You know it as a student of library science, that it has become so easy for the process of reviewing, for the process of communication. You understand? Within the last 25 years, the whole thing has changed. I remember when my paper was accepted for presentation in Toronto Conference International conference on classification research. You must have heard the name of Dorking conference. So after 10 years, this international conference on classification research is conducted every after 10 years. So in 1991, in Toronto, the International Conference on Classification Research was being organized. My paper was accepted. That was the first experience. Experience in the sense that we were not so much developed. There were hardly any computers in the university. There was only 2 laser printers. One was in the Department of History and another was in the Department of Mathematics. And they used to be very closely guarded. Nobody should touch them, otherwise it will be broken. That was the idea. Okay. But there the organizers, when they accepted my paper, they sent an instruction manual, small, that your paper should be on A4 size, margin should be this much, the font should be this much, the size should be this much, the spacing should be this much. That way it was first experience. So I was running from pillar to post. What to do? I also did not know. I had to learn some computer in Muzambil Manzil. There was some private sort of this computer shop, imparting training. Talk about a week or so. MS Word. We learned MS Word. Then we tried to do something. Then we showed somebody who was an expert whether we have done it correctly or not, because we didn't want to miss the opportunity. Okay. Then ultimately it came how to get it printed through a laser printer. We had not seen the laser printer in 1991. So then came to know that in Professor Irfan Habib's room, there is one laser printer in this department of history. It is an advanced center. So I approached through somebody, Professor Irfan Habib, so he allowed. So floppies chala karte hain, floppy, soft. On the floppy we did something, everything set, and then took out the print. Then it was sent by post. Okay, there was no email that time. There was no email. So you can see the hardships in which people used to work. Naturally, it will affect the productivity. Now the productivity is far more. When you are talking of the productivity of authors, you have to keep in your mind the circumstances in which the scientists have been working. Naturally, it will affect the productivity. So what I mean to say is that don't take Bradford's law as if it is a last word. It is not a last word, but it shows a method of research. It shows a way of research. You can take any literature, any subject, any period, collect the number of authors total, collect the number of authors, single authors who have contributed one paper each. Then apply Lotka law. Then do the counting. Like this, on one side you put your own counts. On the other side, by applying Lotka's law. See the difference. Then try to find out the equation. If it is not fitting into 1 upon n square, then where it is fitting into n square or more. Okay, like that you have to find out your own modified Lotka's norm. Alright, so that's all for today.